How to graph absolute value functions. So let's review what absolute value means. An absolute value is the distance from zero on the number line. So even a negative number will have an absolute value that is positive. It's the distance from zero. So for example, the absolute value of 6 is 6 because it's 6 away from 0. The absolute value of negative 6 is also 6 because it's still 6 away from 0, just in the opposite direction. So let's find the absolute value of these numbers. The absolute value of 6 is 6. The absolute value of negative 2 is 2. So all of our answers are always going to be positive for the absolute value. For C, we have the absolute value of 0 minus 5. Well, 0 minus 5 is negative 5, and the absolute value of negative 5 is 5. The absolute value of 1 minus 8 would be negative 7. The absolute value of negative 7 is positive 7. Okay, so now let's evaluate a function that has absolute value. So we're going to be substituting in the value of x and then finding the value of the function. So for f of 2, we will do the absolute value of 2 minus 2 plus 3. Well, 2 minus 2 is 0, so we have the absolute value of 0 plus 3. The absolute value of 0 is 0, and 0 plus 3 is 3. Let's find f of 5 with the same function. So the absolute value of 5 minus 2 plus 3. 5 minus 2 is 3. So we have the absolute value of 3 plus 3. The absolute value of 3 is 3. And 3 plus 3 is 6. Let's find f of negative 5. So we have the absolute value of negative 5 minus 2 plus 3. Negative 5 minus 2 is negative 7, so we have the absolute value of negative 7 plus 3. And the absolute value of negative 7 is 7, and 7 plus 3 is 10. So let's look at an absolute value function in vertex form. F of x equals a times the absolute value of x minus h plus k. This is very similar to quadratics in vertex form, where we need to find h and k. For h, we're going to use the opposite sign. And for k, you keep the same sign. So for example, if we have f of x equals negative 1/4 times the absolute value of x minus 1 plus 3, then for this function, h is positive 1 and k is 3. The axis of symmetry for this function would be x minus h, so x equals h. So x equals 1 is our axis of symmetry. The vertex is 1, 3. And we would put that into our table in the middle row. Then we identify 2 x's to the left and 2 x's to the right. So we're thinking on the x-axis, the two numbers to the left would be 0 and negative 1, and the two numbers to the right would be 2 and 3. Now we're just going to substitute this in to fill in the rest of the table. So these are our x values. We'll use this function and solve for y. So the first thing I like to do is rewrite the function with, instead of the absolute value portion, I'm just going to put a parentheses. So this is what I'm going to type into the calculator, but I have to solve the absolute value portion first. So that's what I'm going to do here next to my table. It's the absolute value of x minus 1. So in this case, negative 1 minus 1 is negative 2, and the absolute value of negative 2 is positive 2. That's what I'll put here. I can plug this into the calculator to get my y value. So that would give me 2.5. Now I'll erase this and move on to the next part. So now I'm going to substitute in 0 for x. 0 minus 1 is negative 1, and the absolute value of negative 1 is positive 1. That's why I put what I put here in the parentheses, put that into the calculator, and I get 2.75. So if your calculator is giving you a fraction, just hit that convert button above enter, and it converts it to a fraction for you. Next we have 2. 2 minus 1 is 1, and the absolute value of 1 is 1. So again, I'm going to get 2.75. And then 3 minus 1 is 2, and the absolute value of 2 is 2. So this again will be 2.5. So just like in quadratics, we have these repeating y values. All right, let's do a full example where we actually graph it. So here is my function, f of x equals 1/2 times the absolute value of x minus 3. So first we identify h and k. H is positive 3, and I don't see a number after the absolute value, so that means that k is 0. You can imagine like a plus 0 right here. So my axis of symmetry is x equals 3. I am going to go ahead and draw my axis of symmetry at x equals 3. My vertex is 3, 0. So 3, 0, that should be right on your axis of symmetry. And this goes into the table in the middle. The two x's to the left of that are 2 and 1, and the two x's to the right are 4 and 5. So now I need to plug this in to fill in the rest of the table. So again, I'm going to write, this is just my preference of how to do it, is to replace the absolute value with parentheses here. And then I'm going to solve the absolute value portion over here to the side. So I'm substituting in these x values here. So I'm going to solve just the absolute value portion. We have 1 minus 3. That would be negative 2, and the absolute value of negative 2 is positive 2. So I'm going to put positive 2 here. When I put that in the calculator, 1/2 times 2, the answer is 1. Now I can erase this and go to the next line. So next I'm substituting in 2. 2 minus 3 is negative 1, and the absolute value of negative 1 is positive 1. Now I can put 1 here. 1/2 times 1 is 0.5. And you can probably guess that these are going to repeat, and go ahead and fill in the rest of it. Or if you want to be extra sure, go ahead and calculate it. That would give you 1/2. and that would give you 1. So all we do now is plot these points from the table into the graph. 1, 1, 2, 1/2, 4, 1/2, and 5, 1. The domain will be negative infinity, infinity. For all absolute value functions, that's the domain, negative infinity, infinity. My range for this will be, the bottom is the y value, so 0. And then it goes to infinity in the range. Okay. If you feel like you understand it, you can move on to the practice. I do have 3 more examples to go through if you feel like you need that practice. Okay, let's identify h and k. Remember to change the sign of h. So h is going to be -1, k is -2. Axis of symmetry is x equals -1. And the vertex is -1, -2. We can put that in the table and plot it. -1, -2. It should be right on your axis of symmetry. And now let's identify 2 x's to the left. That would be 0, nope, sorry. That would be -2 and -3. And 2 x's to the right would be 0 and 1. Now, again, this is the way I like to do it. I'm going to replace that absolute value portion with a parentheses. And I'm going to evaluate the absolute value portion off to the left and then plug that into those parentheses. So we have the absolute value of x plus 1. So this is going to be -3 plus 1. -3 plus 1 is -2, and the absolute value of -2 is 2. I can put 2 there, plug that into the calculator. 2 times 2 minus 2 is 2. Erase this, move to the next line. So now I have -2 plus 1. That would be the absolute value of -1, which is +1. Now I can put +1 in my parentheses. 2 times 1 minus 2 is 0. And now I'll just plug in the rest of the values. Again, you can evaluate the rest if you want to, but these should repeat and these should repeat. Plug it into, or plot it on the graph. -3, +2, -2, 0, 0, 0, and 1, 2. The domain will always be negative infinity, positive infinity. The range, since my V shape is pointing up, the bottom of the range will be that y value, -2, to infinity. Number 3, identify h and k. So there is no minus or plus inside that absolute value. So that means that h is 0 and k is 7. Axis of symmetry is x equals 0. And the vertex is 0, 7. Two x's to the left and two x's to the right would be -1, -2, and 1, 2. I'm going to rewrite my function with parentheses instead of the absolute value and evaluate this absolute value off to the side. So the absolute value of -2 is +2. So I'm going to put +2 here. Plug that into the calculator or do it in your head. -2 plus 7 is 5. The absolute value of -1 is 1. So -1 plus 7 is 6. And now I can just fill in the rest of this here and plot my points. -2, 5, -1, 6, 1, 6, and 2, 5. So this V shape is pointing down. Domain is -infinity, infinity. My range, since it's pointing down, we're going to use -infinity, and the top will be the y value of the vertex. Last example, if you need it, h is +5, k is 4, the axis of symmetry is x equals 5, the vertex is 5, 4, so there's my vertex, 2 x's to the left and 2 x's to the right. I'm going to rewrite my function using parentheses where the absolute value is and evaluate the absolute value over here. So I'm going to substitute in (3 minus 5), which is -2. Absolute value of -2 is +2. Put that into the calculator. -3 times 2 plus 4 is -2. Now we're going to do 4 minus 5. That's -1. Absolute value of -1 is +1. -3 times 1 plus 4 is +1. Now I can fill in the rest of this and plot the points. 3, -2, 4, 1, 6, 1, and 7, -2. The domain is -infinity, infinity, and the range will be -infinity to 4. And that's what you're doing today's practice.